For today's video, we are going to go over 6.2 exponential function practice number 1. So for bell work, remember it's its own unit. So these are exponent properties. So for number 1, for the exponent properties, we only know 2 so far: 0 exponent and negative exponent. So let's get rid of the 0 exponent first. So we learned that anything to the 0 power is a 1. However, the negative is kind of hanging out there. So if that negative is hanging out on the side, it really means a negative 1. Now later on, we're not even going to write that 1, but I just want to show you that negative 2 raised to the 0 power became that number. So now we have a negative exponent. It's attached to the y base. It's in the denominator, so I have to move the location. Remember alphabetical order, please. Now notice I did not touch the z squared on the bottom, so it's going to stay. Now, technically you could write that negative 1, but for this to be marked correct, because remember it's a computer program, please leave 1 off of it, and z squared. All right, we're good to go. Now for number 2, we have that negative 25. Be careful here. That 25, or that negative 25, is the base. So we are just talking about negative exponents when we have to move them. Exponents are the smaller number in the air. So the ones that you have to move are x to the negative 3 and y to the negative 4. We don't touch a negative base. It stays put. Negative 25 equals negative 25, so make sure that you keep it there. All right. So the fraction goes away, and we're just left with negative 25 x cubed times y to the 4th. Now we're going to get on to the main lesson, the exponential functions. And we're going to really talk about the initial value and the constant ratio, and setting up an equation in y equals a times b to the x. Now here are the footprint, or the template, to linear equations and exponential equations. So up top we have y equals mx plus b. So we spent first semester talking about linear equations. We have to remember that our m really meant a constant rate of change. That's why we had rise over run, and that's why we got a straight line. Now, exponential equations, on the other hand, have a constant ratio. So that is the base, b, of the raised to the x power. We call that a constant ratio, so it's a b value. But we want to be careful, because this is something brand new, meaning that each point is repeatedly multiplied by the same value. So we're going to be multiplying here. And to make more sense of that is the next slide. So comparing constant rate and constant ratio. So if we had a normal linear equation, y equals 2x, it was increasing by 1s on the x, increasing by 2s, by adding 2, by adding 1. And then if you did the difference of the y's, which was 2, over the difference of the x, which is 1, you would have gotten a slope, or a constant rate, of 2. But if you move down to this table, this is our exponential. Notice that we are no longer doing adding, we're doing multiplying. So this is a constant ratio because 1 times 2 gets you 2. 2 times 4 gets you, 2 times 2 gets you 4. 4 times 2 gets you 8. And then so on and so forth. If you are not good with the multiplying, you can always work backwards. What I mean by that is take the bottom y value, 8, and then divide it by 4. You're going to get 2. And that's our constant ratio. You're going to do 4 divided by 2. You're going to get 2. You're going to get the same multiplication factor or the same constant ratio every single time. So that's one way to work backwards. Now let's come up with, how are these y values changing? What is it being multiplied by? It says these points represent an exponential equation with a mystery constant ratio. Looking at the pattern of how the values change, can you guess the b value? So we have these y's. We have 3, 9, 27, 81. What is it being multiplied by to get to the next number? And it's going to be 3. It's going to be multiplied by 3. If you don't see that right away, remember, 81 divided by 27 gets you 3. You can keep going down the line. 27 divided by 9 gets you 3. 9 divided by 3 gets you 3. That is the constant ratio. So that's a multiplication pattern. Let's check our answer on the next slide. Our curve goes through exactly what we need to. We have a smiley face rotating. And then the second part of the equation, the a value. In this one, what do you think will happen with the graph as the a value changes? The a value is the initial value. So it's the starting point. It's wherever, if we're talking about money being invested, it's the amount of money you put in a bank. If we were talking about population of an animal, talking about the population you started at the year that you started recording, what's happening to the population. So it's really the starting amount. So it's a starting amount. So when the a value changes, I guess I should put kind of like in quotes so you can see that better. So does the y-intercept. So let's check it out on slide number 8. Notice when the slider is at a equals 1, the graph intersects at 1. Let's move it to 2. It moves up. 3, 4, 5, 6. So just to make sure that you're visualizing this, the y-intercept is changing every single time the slider is changing to the number that is a, because the a in this case represents the y-intercept. So you can just say the a is the y-intercept or initial value. All right, let's put this all together. It says we're going to write in blue the initial amount. We're going to write in in red constant ratio. And then, of course, the x is the exponent. So let's find the color blue. Circle the initial value in blue. That's our a value. Also, you can find it on the table. And you can also find it on there, on the graph at the y-intercept. All right, now circle the constant ratio in red in the equation. Constant ratio is the base of x. Now show the multiplication pattern, which is a constant ratio. Because 16 times 1/2 is 8. And you can do it as a decimal too. 8 times 0.5 is 4. 4 times 0.5 is 2. And then 2 times 0.5 is 1. So you can show it that way as well. Now this is what you are going to be assessed on. So the A value here, we already talked about, is the y-intercept. So the A in this case is 2. You can find it from the graph, or you could find it from where x equals 0. Now the pattern is going to be the hardest part. So if you need to, write, okay, what is, 18 divided by 6? It's 3. What's 6 divided by 2? It's 3. And I could keep doing this over and over again, but that is going to be the B value. So let's check it. We know the format is 2 times 3 raised to the x. And we know we got it correct. Now, if you wanted to use parentheses instead of the multiplication symbol, just make sure that the x is hanging on the outside, and then you are good to go. Now, for this graph, we want to look at the initial value and the constant ratio as well. So remember that the constant ratio is the y-intercept. So you can either find it on the y-axis or when x equals 0, which in this case, the A will be 4. Now remember, the constant ratio is just, it's division, right? But, or at least when you think of, I guess I should rephrase this, when you see the word ratio, you think a fraction, okay? Now, if you can't come up with a pattern, 36 times what gets you 12? 12 times what gets you 4? You want to work backwards, okay? I recommend staying away from fractions, but look at these two numbers right here. Start backwards, okay? So it's kind of like thinking y2 divided by y1. So we have 4 divided by 12. 4 divided by 12 simplifies, and I recommend keeping it as a fraction because this is a repeating decimal. So if you just put in 0.33, it's not going to be correct. So just keep it as a fraction if you get a fraction. Unless you have a terminating decimal, then that would be acceptable. If you don't like 4 over 12, try 12 over 3 or 36. You're going to get that 1 over 3 still. If I could write 1 divided by 3, sorry. So that's your B value. Now, once again, remember the equation. You can use parentheses. You can use the multiplication symbol. Just have the x in the exponent. It goes through. Good work. Now, this is called a decay. So let's look. Let's think about our domain. These have arrows on the end. How far left does our graph go? How far right does it go? since our graph keeps going on and on and on and keeps going more left and left and left, it's heading towards negative infinity. How far right? It's heading towards positive infinity. Now for our range, you want to think about what is this graph trying to sit on? What y value is this graph trying to sit on? And it's trying to sit on 0. This whole line is 0. And then how far up is this graph trying to go? It's trying to go to positive infinity. Remember, just write out the word infinity. The symbol will show up. No spaces. It will never get to 0. That's why we're using the parentheses. Oh. Make sure you type it right, guys. Now, what's the y-intercept here? It looks like 0, 4. And then once again, y equals 0 because that is what it's trying to sit on. When you get into Algebra 2, these numbers are going to change, but whatever your smallest y that it's trying to approach, it's going to be what your asymptote is. So just giving you a heads up. All right, the next problem. Let's look here. Once again, your a value is 8. We can confirm that on the table. The b value, I'm just going to go straight into division. I like those two numbers, y2, y1. So 8 divided by 16 gives me 1 over 2. If you want to double check, of course you can. Let's choose those two numbers. Once again, I get 1/2. Remember, it's multiplying, okay? Some students said yesterday, oh, I'm going to be dividing by 2. Well, you want to think of it as multiplying. So what is the same thing as dividing by 2? It's by multiplying by 1/2. So that pattern is always in terms of multiplying. So keep that in mind as we progress in this topic. So let's confirm our initial value is 8. Our multiplication pattern is 1/2. All right, looks good. Now for this, how far left does my graph go? Goes on for negative infinity. How far right? Positive infinity. Your range is always, your domains is always going to be that. For this class, your range is always going to be 0 to positive infinity. What is the y-intercept? It looks like 0, 8. And then once again, the asymptote line is y equals 0. You're good to go. All right, let's identify the y-intercept. The y-intercept is 1. Let's confirm that. So our a equals 1. And then our b value, our multiplication pattern, I'm going to choose the bottom two. So I'm going to do that y2 minus y1. And it's not really y2, I'm sorry, not y2 minus, y2 divided by y1. It's not really y2 and it's not really y1. It's just for my brain to remember that I got to start from the bottom and go up. So then we're going to get 6. And you can check that pattern out. If you actually put 1 over 36 times 6, you're going to get 1/6. 1/6 times 6, you're going to get 1. So on and so forth. So let's put that into this equation. Now you're going to notice that you do not need that 1. Most of the time, the equation, if the y-intercept is 1, you are just going to see the function y equals 6 raised to the x power. And that's going to be the same thing. So if you don't visibly see an a value, just know that it's 1. All right, lastly, how far left does this graph go? It's going to go negative infinity. How far right? Positive infinity. The range, the graph is trying to sit on 0. It's approaching. It's getting smaller. Remember those decimals, 0.0000009, 0.0000007. So you can go on forever, and it's never going to reach at 0. In this case, the y-intercept is 0, 1. We can look right on this axis. And then the asymptote is the line that it's trying to sit on. So it's y equals 0.